Welcome everyone. In this tutorial, we are going to show you how to build this LED keychain using 3D printers and electronics fabrication equipment available at the makerspace. This activity is inspired by a design exercise that we propose in APPL 110, one of our Introduction to Engineering courses at UNC. Along with this video, you can find a link to download an STL file that you can use to print the case of your keychain using the 3D printers at BEAM. Here we will show how to assemble the components on the printed circuit board. You should have a switch, a battery holder, a button battery, a LED, and a resistor. And you will need to use the soldering station available at BEAM. This is the front side of the PCB and the back side. The components will be placed on the front side, and the soldering will be done on the back side. We begin by placing the battery holder, which we clip on the front side. We secure the PCB with the back side facing up, and we solder the battery clip. For this, we bring the tip of the solder iron at the junction where the pin of the clip passes through the hole, and we add just a little bit of solder, enough to make a connection, but not too much to avoid overfilling the hole. And we do the same thing on the other side with the other connection. This is what the battery clip looks like once it's in place. The next step is to place the resistor. So for that, we will bend the two legs of the resistor at 90 degrees, quite close to the resistor. And then we will insert each leg in the two holes on the either side of the resistor labeled R1 on the PCB, again with the resistor on the front side of the PCB. There is no polarity on the resistor, so it doesn't matter which of the left or right leg goes into which hole. So once the resistor is in place, again we're going to hold the PCB facing the back side up, and as we just did before, we will solder each of the leg with a little bit of solder to fill the hole and establish a connection. Once the connection is made, we use wire cutters to cut the extra leg flush with the board. And this is what the resistor looks like once it's in place. The next component we want to place is the LED. It has a long leg and a short leg. The long leg is the anode and the short leg is the cathode. The LED will only work if the current flows from the anode to the cathode. If you mount it in reverse, the circuit will not turn on. The cathode is also marked on the base of the LED with a little flat edge. That same flat edge is shown on the PCB with a little drawing, and all you need to do is to match the flat edge on the LED with the flat edge on the PCB. Once the LED is in place, you can place the board again face down with the backside facing up. And the first thing to do would be to solder one of the legs with a soldering tip and a little bit of solder, as before, with just a little bit of solder. And you may notice then the LED is not flushed with the PCB. So you can melt again the solder junction and realign the LED until it's in place. When the LED is correctly in place, you can then solder the other leg. If needed, you can hold the PCB in place with a clip. And after you solder both legs, you can use again the wire cutters to cut the extra leg length and cut the junction flush with the PCB. And this is what the LED looks like once it's soldered in place. The next component we place is the switch, which we insert on the front face with the lever facing outwards. And then we turn the PCB around, looking at the back face. And what we're going to do here is solder one of the pins, just like we did before. And as we did for the LED, we're going to check that the switch is correctly in place. You can see it's a little bit tilted, so we can remelt the junction and make sure the switch is correctly in place. Once the switch is correctly in place, we then solder the other pins. There is 3 connection pins, and around them 2 mounting pins that are connected to the case of the switch. Here it's important to make sure that we don't put too much solder and don't create any shortcut between the legs. If you put too much solder, there are soldering pumps and desoldering wire that you can use to remove solder and fix the connection. So this is what the switch looks like once it's been soldered. The last part is to insert the button battery in the clip with the plus facing up, and you can see that the circuit turns on and off as you switch the switch between its on-off positions. The last thing to do is to put the PCB inside the case. So we put the PCB face down in the case so the LED exits through the hole, and then we put the cover in place. Everything should clip together nicely. We then use the 2 screws that are provided in the kit to secure the cover, the PCB, and the case together. You may need to clean the holes before you set the screws in place, as some debris might be there left from printing and some support material. Otherwise, the screws are self-threading, and this is what the device looks like at the end. Thank you for your attention.